Hello everyone, welcome to T5L training. This time, I will show you how to realize Modbus communication with our screen. The main contents are divided into master, slave, and using Modbus to realize the simple application of reading and writing database. The first part is screen as master. First we need to download the Modbus kernel. In this way, our screen can parse the Modbus program and achieve communication. There are kernel resources in DWIN official website. Choose the appropriate kernel according to the master or slave, baud rate, serial port number. Open the download folder and this is the Modbus kernel. It's worth noting that our Modbus kernel has been updated, so don't download old DWIN OS v7 kernels provided by others. Otherwise, it will conflict with our next settings, resulting in no communication. In the second step, we need to set up DWIN software. Provide the UI interface for our screen. These are the application interfaces of this time. Because it is the screen as the master, I set the master read slave data and write slave data 2 pages. 00 page, I plan to use this area to read data from the slave. We can use variable icon display control to realize it. As for their VP addresses, I set them from 1000 to 1027. Then, using the basic touch module to jump from the current page to page 01. The 01 page is used to write data to the slave. The blue areas are used to display data, and the yellow areas are used for data entry by touch. And I set the VP address of 3 parameters from 2000 to 2002. This area are the keyboard values. Next, we need to set the commands for reading and writing data in 22 files. According to the development guide, we need to start writing commands at address 1C000. Look at this command. 5A is the command start flagged. If it is any other value, the command will not be recognized by the screen, resulting in an invalid command. 01 is slave ID. We usually set the slave ID to 01. 03 is Modbus function code. There are a lot of function codes, we mainly use 03, 06, 10. 03, you can think of it as reading VP address data. 06 indicates writing data to a single VP address. 10 indicates writing data to multiple VP addresses. Back to the commands. 10 is the data length in bytes. 80 is receive timeout in milliseconds. 00 is the execution mode. There are 5 main execution modes. 00 is executed in any page. 01 is executed under the specified page. 02 equals execute when the specified key value is triggered. 03 equals in the 0x06 function code, when the value of the variable pointed is non-zero, it is automatically sent. 04 equals in 0x05, 0x06, 0x10 function code, it will be sent automatically when the specified variable changes. If you need to specify the page, specify the key value, automatically upload these special functions, you can later try to develop yourself. Since we have no special circumstances, we only need to use 00 mode this time. These contents can be seen in the Modbus document, I have put it into this project resources, you can download if you need. Back to the commands. Since we choose 00 mode, there is no need to configure it here. Set it to 0000. 1000 indicates the VP address. 0064 indicates the register address of the slave. In 22 file. Click the icon and enter 0x1C000. You can jump to the 0x1C000 address. Look at this command at address 0x1C000. It means reading slave data. 5A is the command start flag. 01 is the slave ID. 03 is the Modbus function code. Reading VP address data. 10 is the data length in bytes. 80 is receive timeout in milliseconds. 00 execute mode. Commands can be executed in any page. These 2 bytes after 00 mode do not need to be configured, so it is 0000. 1000 is the VP address of page 00. 0064 is the slave register address. Look at the second command at address 1C010. It represents writing data to the slave. 5A is the startup flag. 01 is the slave ID. 10 is the Modbus function code. Writing data to multiple VP addresses. 06 is the data length. This is because the 3 parameters of page 01 take up 6 bytes. 80 is receive timeout in milliseconds. 00 execute mode. Commands can be executed in any page. The 2 bytes after 00 mode do not need to be configured, so it is 0000. 2000 is the VP address of page 01. 006E is the slave register address. Since I want to show the communication between the master and slave, I use the PC as a virtual slave. And here is about slave settings. I set the slave ID to 1, the same as the slave ID in the 22 file. Set the address to 100. And set the quantity to 20. It means that slave addresses contain 100 to 119, a total of 20 addresses. You can see here that 0x64 represents the slave address 100, and 0x6e represents the slave address 110. Keep the slave addresses consistent so we can communicate correctly. Now, please follow me to do it. First, open the DWIN official website and select Download Kernel Upgrade. Scroll down to the Modbus section. Select Modbus Master. Since I use serial port 5, baud rate 115200, so I choose its corresponding folder to download. Open the folder, and this is the Modbus kernel we need. And this is the Modbus OS file. If you know more about DWIN OS, you can add more Modbus functions in it. Next, open the DWIN software. Click New. And set the resolution to match that of your screen. Then set the file path and click OK. Click the plus sign and select the background image. The image needs to be named from 00 onwards. Next, we need to generate 32 to ICL background image. Click Welcome, then click DWIN ICL Generator. Select the background image directory and click Generate. Select DWIN Set folder. Name it 32 to ICL file. Then click Touch and Display Config. First, we need to display the data in this area. Select Data Variable Display Control. Box select Display Area. In the Parameter Settings section, VP address 1000 to FFFF are available for users. So I set its VP to 1000. Show Color select Black. Font size select 16. Alignment select Center. Variable type select int 2 byte. Integer digits select 2. Then copy the control 7 times. change their corresponding VP address. Select the second control and change the VP address to 1001. Select the third control and change the VP address to 1002. The latter are similar. Copy these 8 controls twice and change the corresponding VP address. Set up a page switch. Select Basic Touch Module. Box select Touch Area. Page switch select Page 01. This completes the data display. Click on Page 01. Set a page return effect. Select Basic Touch Module. Box select Touch Area. Page switch select Page 00. Then set the touch input control here. Select Variable Data Input. Box select Touch Area. VP address select 2000. Variable type select int word. Integer digits select 2. Decimal digit select 0. Show location indicates the location of the cursor. You can choose the center of this area. Show color select black. Font size select 16. Display method select direct display. Keyboard setting select the current page. Click Keyboard setting. Select Page 01. Box select the keyboard area. Show location is the same as the coordinates on the left. Then select Variable Icon Display. Box select Display Area. VP address select 2000, which is the same as the touch control. Show color select black. Font size is set to 16. Variable type select int 2 byte. Integer digits select 2. Decimal digit select 0. Then copy the 2 controls twice. Change the corresponding VP address. Click the second parameter control and set the VP address to 2001. Click the third parameter control and set the VP address to 2002. Next is the keyboard value setting. Select Basic Touch Module and box select Touch Area. Follow the text prompts here. The key value of 7, enter 0037. Then copy the control and enter the corresponding key value. Key 8, fill in 0038. Key 9, fill in 0039. The latter are similar. Backspace enter 00F2. Clear enter 00F0. Return key enter 00F1. Finally, generate the file and click Save. Open the DWIN set folder. Copy the Modbus kernel we just downloaded into the DWIN set folder. Open the 22 file. Click this icon and enter 0x1C000. Jump to the 0x1C000 address. The first is the command to read slave data. 5A is the startup flag. 01 is the slave ID. 03 is the Modbus function code. Read VP address data. 10 is the data length in bytes. 80 is receive timeout in milliseconds. 00 execute mode. Commands can be executed in any page. The 2 bytes after 00 mode do not need to be configured, so it is 0000. 1000 is the VP address of page 00. 0064 is the register address of the slave. Then the second command, write data to the slave. Go to address 1C010. 5A is startup flag. 01 is slave ID. 10 is Modbus function code. Write data to multiple VP addresses. 06 is data length. This is because the 3 parameters of page 01 take up 6 bytes. 80 is receive timeout in milliseconds. 00 execute mode. Commands can be executed in any page. And the 2 bytes do not need to be configured. 2000 is the VP address of page 01. 006E is the register address of the slave. Save 22 files. Since 22 files will be overwritten after the project update, we need to make a backup of 22 file. Copy the DWIN set folder to the SD card for burning. And we can get the Modbus master project. Next comes the wiring part. This time I use this model, which contains 3 serial ports. I choose serial port 5 for RS485 communication. Look at this picture. This is the screen with 8-pin 3.81 socket. This is an adapter board that converts RS485 signals into USB signals. This is PC. This is the DC port. This is 12V power supply. Look at this. The black line is the ground line of the DC port, which is connected to the GND of the socket. The red line is the power line of the DC port, which is connected to the VIN of the socket. Then connect the DC port to the 12V power supply to power the screen. For RS485 communication, connect terminal A of the screen socket to terminal A of the adapter board. Connect B to B. Then connect the adapter board to the PC via USB cable. And this allows the screen to communicate with the PC. Now let's connect the screen ourselves. These are the screen and accessories we need to use today. This is the screen. It has 8-pin 3.81 socket. This is the adapter board. You can purchase a suitable adapter in your local area, and don't forget to install the adapter driver on your PC. This is the DC port. T is separated from the accessory HDL65011. These two are the red and blue DuPont wires. This is a USB cable. This is 12V power supply. This is a small screwdriver. This SD card has the project we were just working on. Now let's start wiring. This is the DC port. It is divided into power supply port and ground port. This single wire is the ground port. We connect it to the GND port on the socket. Then tighten the port with the screwdriver. These 2 wires are the power port. We connect them to the VIN port on the socket. Then tighten the port with the screwdriver. In this way, DC power cable connection is complete. Next we wire the RS485 communication. This is a red DuPont wire. I plan to connect it to port A of RS485. This is the A port on the socket. Connect the red DuPont wire to port A. Then tighten the port with the screwdriver. Find the port A of the adapter board. Connect the red DuPont wire to port A. Then tighten the port with the screwdriver. So our connection to port A is complete. Next, take the blue DuPont wire and connect it to port B. This is the B port of the socket. Connect the blue DuPont wire to port B. Then tighten the port with the screwdriver. Find port B on the adapter board. Connect the blue DuPont wire to port B. Tighten the port with a screwdriver. Next, we take out the USB cable. On the other end, I've connected it to the PC. This end is used to connect the adapter board. You can see the red light is on. That means our connection is successful. Next, we need to burn the project files. Insert the SD card into the slot. Then connect 12V power supply cable to the DC port. Burn the project to the screen. Blue screen showing end indicates that burning is complete. Then power off. Remove the SD card. And power on again. We can see the initial interface. This is the Modbus slave tool. It uses the PC to simulate a virtual slave. Next, we perform a test of reading and writing data to the slave. Click Connection and select Serial Port. Baud rate select 115200. Mode select RTU. Select 8N1 as the data transfer mode. Click OK. Then we set up some slave addresses. Click Setup, the slave definition. As I described earlier, set slave ID to 1. Set address to 100. Quantity select 20. Click OK. This generates 20 slave addresses from 100 to 119. First of all, we test the master read slave data on page 00. Enter 21 at address 100. And you can see 21 appear on the screen. Then set auto increment at address 101. You can see that the numbers on the screen are increasing in sync. Addresses 100 and 2103 are configured with auto increment. The numbers on the screen are constantly changing. Next, we conducted a test of master writing data to the slave on page 01. Enter 10 in parameter 1. You can see that the value of slave address 110 has changed to 10. Then write data 20 in parameter 2. You can see that the value of slave address 111 has changed to 20. Write data 30 in parameter 3. You can see that the value of the slave address 112 has changed to 30. Screen as master test completed. If you're interested in Modbus functions, you can also try to add more function codes in the 22 file for development testing. The second part is the screen as slave. First of all, as for DWIN setting, we can continue to use the previous UI interface. No additional software setup is required. Since the content of this section is to talk about the screen as the slave, the PC as the virtual master. My design idea is that the PC sends commands. and the screen executes the commands of the PC and display the data in this area. Step 2. We need to download the slave kernel from the DWIN website again. Select the appropriate baud rate and serial port number. This file is the Modbus slave kernel. Then copy it to the DWIN set folder. It is worth noting that the screen acts as slave. Therefore, there is no need to configure 22 file. Next is the serial command section. This is the explanation of the commands. 01 is the Modbus slave ID. It is usually set to 01. 06 is the Modbus function code we mentioned before. 2000 is the VP address. 000A is the data. Here we will use these three function codes. 03 indicates reading the VP address data. 06 indicates writing data to a single VP address. 10 indicates writing data to multiple VP addresses. We're going to send these four commands. The first command is to write 10 to VP address 2000. 01 is the Modbus slave ID. 06 is the Modbus function code. Write data to a single VP address. 2000 is the VP address. 000A is the hexadecimal value of 10. The second command is to write 11 to VP address 2001. 01 is the Modbus slave ID. 06 is the Modbus function code. 2001 is the VP address. 000B is the hexadecimal value of 11. The third command is to write data 10, 20, or 30 to multiple addresses starting with 2000. 01 is the Modbus slave ID. 10 is the Modbus function code. Write data to multiple VP addresses. 2000 is the VP address. 0003 is the data length in words. 06 is the data length in byte. 000A is the hexadecimal number of 10. 0014 is the hexadecimal number of 20. 001E is a hexadecimal number of 30. The last command is to read the one-word length data in VP address 2000. 01 is the Modbus slave ID. 03 is the Modbus function code. Read the VP address data. 2000 is the VP address. 0001 is the data length in word. Now please follow me to do it. Let's open the DWIN software that we just made the project. Still keep the original software settings, do not need to modify. Open the DWIN set folder. Delete the original 22 files and master kernel files. Generate the project and save. Then open the official website of DWIN and select Download. Kernel Upgrade. Scroll down to the Modbus section. Select Modbus Slave. Since I am using serial port 5, baud rate 115200, so I choose serial port 5 115200 to download. Open the folder and this is the Modbus kernel we need. Copy it to the newly generated DWIN set folder. Then copy the project to the SD card. Insert the SD card into the slot. Power up the screen. Burn the project to the screen. Blue screen showing end indicates that burning is complete. Then power off. Remove the SD card. and power on again. We can see the initial interface. Now let's start the command test. Open the Serial Port Assistant tool. Turn to the next page. COM number, select COM5. Open the serial port. Then remember to add the Modbus check code and select Modbus CRC16. The baud rate is set to 115,200. The first command is to write 10 to VP address 2000. 01 is the Modbus slave ID. It is usually set to 01. 06 is the Modbus function code. Write data to a single VP address. 2000 is the VP address. 000A is the hexadecimal value of data 10. Click the command. We can see that parameter 1 shows data 10. The second command is to write 11 to VP address 2001. 01 is the Modbus slave ID. 06 is the Modbus function code. 2001 is the VP address. 000B is the hexadecimal value of data 11. Click the command. We can see that parameter 2 displays data 11. The third command is to write data 10, 20, or 30 to multiple addresses starting with 2000. 01 is the Modbus slave ID. 10 is the Modbus function code. Write data to multiple VP addresses. 2000 is the VP address. 0003 is the data length in words. 06 is the data length in byte. 000A is the hexadecimal number of 10. 0014 is the hexadecimal number of 20. 001E is a hexadecimal number of 30. Send the command. We can see that these three parameters display data 10, 20, or 30 respectively. The last command is to read the one-word length data in VP address 2000. 01 is the Modbus slave ID. 03 is the Modbus function code. Read the VP address data. 2000 is the VP address. 0001 is the data length. The unit is word. Send the command. Look at the commands coming back from the screen. 01 is the Modbus slave ID. 03 is the Modbus function code. 02 is the length of the return data in byte. 000A is the hexadecimal of data 10. This is CRC code. Last time a friend left a message. How to read and write database with Modbus. Next, I'll take a brief talk about how to do that. First, we need to open the T5L LCD application development guide. Go to the System Variables Interface section. 04 address, controls system reset. It's 2 words long. Write commands at 04 address, 55AA5AA5. The T5L CPU will be reset once. 08 address controls, NOR flash. Length of 4 words equals 8 bytes. So these 8 bytes hold different things. This is its description. I've drawn a diagram of this part, so it's easier for you to understand. The 7th and highest byte indicates the operation mode. 5 equals read. Of 5 equals write. Bytes 6 through 4 indicates the head address of NOR flash. The start address is 000000, and the address must be even. Bytes 3 through 2 indicates the VP address. It also has to be even. Bytes 1 through 0. The data length is in byte. It has to be even. According to this diagram, we get the following two commands. The first command is writing the VP address data to flash. The 7th byte is A5. Indicates write. Bytes 6 through 4. NOR flash address 000000. Bytes 3 through 2. VP address write 2000. Bytes 1 through 0. Data length write 0004. The second command is reading the flash data into the VP address. 5A indicates read. 000000 is the NOR flash address. 2000 is the VP address. 0004 is the data length. So how to read and write flash with Modbus? We just need to write the command we just talked about at address 08 with Modbus command. It is equivalent to nesting commands inside the commands. Here's an example. This means that writing the command to address 08. 01 is the Modbus ID. 10 is a function code, indicating that data is written to multiple VP addresses. 0008 is the address of the system variable. Control NOR flash. Since 08 address takes up 4 words equals 8 bytes. The data length. 0004 means 4 words. 08 means 8 bytes. Then there's the data content. You can write commands inside. A 50000000, 2000, 0004. The VP address data is written to the flash. Let's do more stretching. As for Modbus read and write database, all it takes are the following 3 commands. The first is to write the VP address data to flash. 01 is the Modbus ID. 10 is a function code, indicating that data is written to multiple VP addresses. 0008 is the address of the system variable. Control NOR flash. 0004 means 4 words. 08 indicates 8 bytes. This is the data content. A 50000000, 2000, 0004. The VP address data is written to the flash. The second is to read the flash data into the VP address. 01 is the Modbus ID. 10 is a function code, indicating that data is written to multiple VP addresses. 0008 is the address of the system variable. Control NOR flash. 0004 means 4 words. 08 indicates 8 bytes. This is the data content. 5 is 000000, 2000, 0004. Read the flash data to the VP address. The third item indicates a restart. 01 is the Modbus ID. 10 is a function code, indicating that data is written to multiple VP addresses. 0004 is the address of the system variable. The CPU is reset. Procedure 0002 indicates 2 words. 04 indicates 4 bytes. This is the data content. 55AA5AA5, the T5L CPU will be reset once. Now let's actually send the commands and see what happens. Back to the serial assistant. This command. It means to write the VP address data to flash. 01 is the Modbus ID. 10 is a function code, indicating that data is written to multiple VP addresses. 0008 is the address of the system variable. Control NOR flash. 0004 means 4 words. 08 indicates 8 bytes. This is the data content. A 500000020000004. The VP address data is written to the flash. Click the command. The data in VP address has been written to flash. This restart command. 01 is the Modbus ID, 10 is a function code, indicating that data is written to multiple VP addresses. 0004 is the address of the system variable. The CPU is reset. 0002 indicates 2 words. 04 indicates 4 bytes. This is the data content. 55AA5AA5, the T5L CPU will be reset once. You can see the screen restarted once. Let's switch to the next page. You can see that the initial values are all 0. This command. The VP address data is written to the flash. 01 is the Modbus ID, 10 is a function code, indicating that data is written to multiple VP addresses. 0008 is the address of the system variable. Controls NOR flash. 0004 means 4 words. 08 means 8 bytes. This is the data content. 5 is 000000, 20000004. Read the flash data to the VP address. Send this command. You can see that the data for all 3 parameters has been restored. Thanks for watching.